Hey everyone, welcome back. In this video, we are starting a super important part of Python, and that is object-oriented programming, or OOP. So it's OOP, which stands for object-oriented programming. If you want to write clean, scalable, and a real-world level Python code, then object-oriented programming is a must-know. So let's understand this in the simplest way possible. So first of all, what is object-oriented programming? So let's explain like a story. So imagine you are creating a game. In the game, there are many players. Each player has a name, a score, and some actions like jumping or running. Now, if we store each player as a bunch of separate variables, it becomes messy. So for example, if I write here like name 1 equal Tom, then score 1 equal 100, then let's say we have another player and that we store in name 2. His name is Bob and score 2 is 120. So if there is more players, the code becomes so much big and this becomes unmanageable. So that's where we want to create a template or blueprint for what a player should be. The blueprint is called a class. Now let me tell you another example without object-oriented programming. So for example, we have a variable called name equal Alex, then age is 25, and we have a function called greet, and there we want to print hello and the name. Okay, and let's call the greet function. Now if I run the code, you'll see it prints hello Alex. Here name and age are global variables. I hope you understand global or local variables. We talked about that in our scope video. And this greet is a function not tied to any specific person. This approach works for tiny scripts but becomes unmanageable as you build more features. Now let's see how we can do this with object-oriented programming, or OOP. Now first of all, in object-oriented programming we have a class. So we write the class keyword and then we give a name for that class. For example, in this case person. Okay, and inside that class we have a special function which is called constructor. So as it is a function, we write the def keyword. Then here comes the interesting thing. When you define the constructor, you must name this underscore underscore init. Okay, now in the parameters we have a self. Now this self parameter refers to the object that is being created, and then after having this parameter in a constructor, we have this parameter. Then we can have other parameters as well, as many as we want. For example, we can have name, then we can have age. Okay, and you can define more parameters, doesn't matter. Now here we can say that self dot name equal name. So then after that we can write self dot age equal age. Don't worry if you are not understanding that much now. I assure that you will understand step by step as we move forward. Okay, now we have our constructor function. We can have other functions as well, the normal functions I mean. So here I can write def, then a function called greet, and here we have this self parameter. Then we can do just print hello, then self dot name. Okay, now let me give you more explanations regarding this code. So this class person creates a blueprint called person. It's like creating a template, and this dash dash init dash dash is the constructor. It runs automatically when we create a new person. We'll learn how to create a new object a few moments later. Now this self.name means this object's name, means the object created with the class person, so the current object's name. and this self refers to the object that is being created, and this grid is a method tied to each object. So before proceeding to understand it better, let's create an object. To create an object, we first take a variable. For example, let's call this p1 equal, then we write the class name which we created here, so person, and in between parentheses we give the params. Now we don't have to pass the self param, but we have to pass name and age in order. So first we pass the name Alex, then we can pass the age, let's say 25. Okay, now we can say here that p1 dot greet, because we created this p1 object with the class person, and there we have a tied function there, and we can call that function using the object because the function is tied to this object. Now if I run the code, you'll see the same output. If I change the name to Naruto and run the code, you'll see it says hello Naruto. So again, p1 is an object or instance of class person, and Naruto is passed to name param, and 25 is passed to the age param. And when we call p1.greet, it uses the values inside that object. So we created this object with the values Naruto and 25. So when we call greet, it uses these values inside that object. Okay, now let me comment this code and let's take another real world example. So let's create a class for car. Okay, now here we have our constructor which is --init. Then here we have this self parameter. Then we can have another parameter called brand, then color. Okay, and here we can write self dot brand equal this brand, which we are gonna pass while creating an object. Now here we are gonna say that self dot brand equal this brand, which we are gonna pass while creating an object. Then we'll say self dot color equal color. Now this function is done. We can have another function called drive. There we have this self parameter, and here inside this function we can print with the string formatting obviously, and here we can write the, in curly braces we can write self dot color, then a space, and again inside curly braces we can write self dot brand is driving. Now the class is complete. Now with this class we can create some objects. For example, we can create car1, and here we're gonna use the car class with the capital C, and here let's say the car brand is Toyota and the color is red. So we are passing Toyota to this brand and color red to this color param. Now we can have another object car2, use the car class, and first of all the brand is Tesla and the color is white. Okay, so as you can see in object oriented programming, everything is kind of object. So as we can see in object oriented programming, we mostly work with objects. So these all are objects. Now here we can write car1 dot drive, and we can write car2 dot drive. Okay, now if I run the code, you'll see the red Toyota is driving. Then in the next line it is saying the white Tesla is driving. So again the car is our blueprint or template. Each car object means this gets its own brand and color. Drive method is attached to each car and uses that car's data, and car1 and car2 are independent objects that don't affect each other. Now there are some key object oriented terms in beginners should know. So first of all, they should know about class, then object, then constructor, then method, and then attribute. So class is the blueprint or the template, as you can see. Object, these are objects we create with that blueprint. Then we have constructor, the function. It is a special method or function to initialize data when creating object. Then method. Now this is easy one, because any function inside a class we call that a method. Then attribute. So attributes are data stored inside an object. For example, these are instance attributes. Okay, now it's practice time. So it's your turn. So create a class called animal. It should have a name and sound. Should have name and sound as parameter. Then add a method or function called makeSound that prints the sound. Okay, now pause the video and try to create this class and the objects and the methods by your own. Okay, have you done that? If yes, then very good. And if you couldn't do that, let's implement that now together. Okay, so let's create a class called animal. So class animal, and there we have this constructor. So dash dash init, and here we give name, then sound as parameter. And in the constructor we say that self dot name equal name, then self dot sound equal sound, and lastly we have to make a function called makeSound. So def make underscore sound, and here we have to print some string with string formatting. So here we're gonna say that self dot name says self dot sound. Okay, now let's create some object with that animal class. So for example, we have an object called dog equal, and let's use that animal class, and here let's pass dog as animal name, then how a dog call or make a sound. So for example, it makes a sound like woof. Okay, and after that we can just write dog dot make sound, so we can call that method. Now if I run the code, you will see it prints dog says off. Okay, now we can have another object called cat, and let's use the animal class, and here the animal name is cat and the sound it makes is meow. Okay, so now we can say cat dot make sound. Now if I run the code, you'll see first it prints dog says off and cat says meow. Now let's discuss some questions that beginners ask. So first of all, they ask that what's the difference between a class and object. So as you can see, class is a template or blueprint, and an object is the actual product created using that blueprint or template. The second question is object-oriented programming or OOP necessary? The answer would be not always, but it makes your code cleaner, organized, and easier to extend for real-world projects. And the third question is, what is self? So this one. So self refers to the current object. It lets the object access its own data. So when we work with dog, then self refers to dog. When we work with cat, then self refers to the cat. And the self lets the object access its own data. For example, this when working with dog, and this when working with cat. So that was your first step into the world of object-oriented programming. You now know what classes and objects are and why object-oriented programming is useful. In the next video, we'll learn how to build the classes and objects in more detail and start building real-world examples. If you found this useful, like, share, and subscribe, and see you in the next class.